Hi everyone, this is your math guru. In this video, I'm going to show you how to use a tree diagram to solve the following questions. A tree diagram for probability is used for organizing and visualizing the different possible outcomes of a sequence of events. In this example, I have, suppose a coin is tossed twice. A, draw a tree diagram to represent all possible outcomes in the sample space. For the B part, we have to determine the following probability of A: 1, a head on the first toss, 2, a head followed by a head, 3, no heads, and 4, at least one head. So for the first part of the question, I'm going to start by drawing a tree diagram to represent all possible outcomes. If we have a coin has two sides, that's the head and the tail. So therefore, on the first toss, we are either going to have a head or a tail. That's our first toss. And the probability of getting the head on the first toss, because there are only two possible outcomes, is 1 out of 2. The probability of getting the tail on our first toss is also 1 out of 2. To find the outcome for the second toss, assuming we have a head on the first toss and we throw the coin again on the second toss, we're also going to have either a head or a tail. So I have that as head or a tail. That's for our second toss. And if peradventure we have a tail on our first toss, for the second toss we're also going to have either a head or a tail on our second toss. The probability of having a head on the second toss, because there are only two faces or two sides to a coin, we're going to have that as 1 out of 2. And the probability of having a tail on the second toss, if we have a head on the first toss, is also 1 out of 2. If we have a tail on the first toss, the probability of having the second toss fall on head will be 1 out of 2. And the probability of having a tail on the second toss, if we have a tail on the first toss, will be 1 out of 2. Now writing out the outcome, we're going to have the probability of having a head on the first toss or head on the second toss. I got that from following my branch of the tree diagram, either a head on the first toss or a head on the second toss. We can also have the probability of having a head on the first toss or a tail on the second toss. We can also have a combination of a tail on the first and head on the second. So I have that as a tail on the first, head on the second, and the last combination will be having a tail on the first and a tail on the second. If I'm to write the probability of each outcome, having a head and a head, that's the probability of having that is 1 out of 4 possible outcomes. The probability of having a head on the first toss and tail on the second is also 1 out of 4. Each of this unique outcome is 1 out of 4 possible outcomes in the sample space. We can also find that by using a tree diagram. If we are to check h and h, we have 1 over 2 times 1 over 2, that will give us 1 over 4. We have 1 over 2 for head and tail on the second. 1 over 2 times 1 over 2 will give us 1 over 4. And we can do that for each and every possible outcome. Going to the second part of the question, we have to determine the probability of obtaining a head on the first toss. If we go back to our tree diagram, to have a head on the first toss, we have a combination of head on the first, head on second, or we have a combination of head on first, tail on second. We're not going to use the other outcomes because we have a tail on the first toss. But the question says we should find the probability of having a head on the first toss. So we have that as 1 out of 4 and 1 out of 4. If we add that together, we have 1 over 4 plus 1 over 4. That will give us, the denominators are the same, so we have 2 over 4. And if we simplify, we have 1 over 2. For the second part, the probability of having a head followed by a head. So we have probability of having, on the first toss we have a head, and on the second toss we have a head. If we go back to our tree diagram, we only have one of such combination as shown. So we have that as 1 out of 4. For the third part, we have to find the probability of having no head. So P of no head. If we go back to our diagram, probability of having no head, we only have that when the first toss is a tail and the second toss is also a tail. And that's 1 out of 4. So the probability of having that combination is 1 out of 4. Note that we can also find out the value by multiplying what we have on our branches. So for tail and tail, we have 1 out of 2 times 1 out of 2. 1 over 2 times 1 over 2 will also give us 1 over 4. The last part of the question, we have to find the probability of at least one head. We have two methods of finding the probability of at least one head. The first method, I can go back to my tree diagram and add all the outcome of having at least one head. I have 2 heads here, I have a head here, I have a head here. So it's either I have 1 head or 2 head. But I'm not going to use the probability of having no head. So that will be 1 over 4 plus 1 over 4 plus 1 out of 4. And that will give us 3 over 4. And I can also find that by finding the probability of having only tail, which is 1 over 4. I'm going to take that from 1. So the probability of at least one head can also be equal to probability 1 minus probability of having no head. So that will give us probability of having no head is 1 over 4. So I have that as 1 minus 1 over 4. And that will also give us 3 over 4. Thanks for watching. Bye.